Hey students, this is lesson 7.28, part 4. In this lesson, we're going to learn how to solve inequalities using more than one step. Let's get right into it here. And just remember some of the rules. If you multiply or divide by negative, you have to switch the sign. Other than that, you can use the same properties of equality that you do when you're solving an equation. So in this first problem, I'm going to start by subtracting 6 from both sides. And that will not reverse the sign, so I'll leave it the same. And I get 15 minus 6 is 9. Then I need to divide both sides by 3, and dividing by a positive number doesn't change the sign. So I just get t is greater than 3. Now, we're going to want to check that solution. So let's just pick a number greater than 3, like 4, and put it in the original inequality and just see if it's true. So I'm going to do 3 times 4 and hope it's greater than 15. And that's 6 plus 12, and 6 plus 12 is 18, and that checks. 18 is definitely greater than 15. So go ahead, you try it. Make sure that if you are multiplying or dividing by negative, that you remember to switch the sign. All right, writing and solving a multi-step inequality. So here's a problem. We want to fence in a rose bed that's adjacent to a deck. The length of the deck is 14. You have at most 44 feet of fence. What are possible widths of the rose bed? So just make a quick sketch here. Here's my deck. And adjacent to it, I think they're talking about making the rose bed like this. Okay, and so we know the length of the rose bed will be 14. We don't know the width. Let's let W be that width. And we have 44 feet of fence, so we can't use any more than that. At most means less than or equal to. So we're going to use that in our inequality. And then we just have to represent the 3 sides that we are combining to get our perimeter of our rose bed, and that would be 14 plus 2W. And then to solve it, we'll just subtract 14 from both sides. And subtracting does not change the inequality symbol. And we're going to divide by 2. Dividing by a positive number doesn't change the inequality symbol either. So we find out that we can use any width up to 15 feet. All right, go ahead, you try the next problem. And you can check back for your answers, see if you're doing it right. All right, let's try another problem. This one we're going to have some parentheses, so we're going to need to use the distributive property. And it's multiple choice. We want to know which is the solution. To figure that out, let's find all the solutions by solving this. The first thing I'm going to do is simplify this by getting rid of the parentheses. So using the distributive property, I get 2t minus 2 plus 3t is less than 2. And simplifying here, we have like terms. We can just combine those and we get 2t plus 3t is 5t minus 2 less than 2. Adding 2 to both sides, we get 5t is less than 4, dividing by 5. And I never multiplied by or divided by negative, so my sign is going to stay the same. I get t is less than 4/5. So any number less than 4/5 is a solution. The only number in this list that's less than 4/5 is 0. All right. So clear the parentheses, just like you would if you're solving an equation first. Go ahead and try that, and you can check back with your answers. Okay, of course, you could have checked any number that was part of the solution. I chose -4, but you could have picked any number less than -3, checking that. All right. If we have variables on both sides, what we want to do is get the variables to one side of the inequality and get the constants to the other side. So in this problem, we have 4n plus 2. Let's, just so we don't have to worry about changing the sign, let's start by getting the variables to the right side of the equation here, so by subtracting 4n from both sides. When we do that, we get 2 is less than 3n minus 13. Then to get the constants to the other side, we're going to add 13. And we get 15 is less than 3n, and divided by 3, we get 5 is less than n. And so I never multiplied or divided by negative, so I didn't have to worry about the sign reversing. So any number that is greater than 5 should be a solution. So let's just try 6. See if that's a solution if n equals 6. So if we let n equal 6, then we're going to do 4 times 6 plus 2 and see if that's less than 7 times 6 minus 13. It should be if it's a good solution. And that's 24 plus 2, 42 minus 13. That's 26, and 42 minus 13 is 29, and that checks. All right. So why don't you go ahead and try that? Actually, just fill in the properties you're using, and you can check back with your solution. All right, on problem number 5, sometimes inequalities will have special solutions, just like when we did equations. Sometimes there's no solution, sometimes any number will work. That can happen with inequalities also. So let's go ahead and check these out. We'll do A over here. 14 minus 6n less than or equal to 2 times quantity 7 minus 3n. And let's clear the parentheses. That won't change our inequality. Let's add 6n, try and get both variable terms to one side of the inequality, and when we do that, we get 14 over here is less than or equal to 14 over here. So 14 is always less than or equal to 14. When that happens, any number will work. So you could say something like all numbers are solutions. Okay? And the second inequality, we have 4p plus 3. It's greater than 9p plus 6 minus 5p. And that one, we're going to start by simplifying the right side. And 9p minus 5p is 4p plus 6. Now let's go ahead and try and get the variables to one side. Subtract 4p from both sides. When we do that, we get 3 is greater than 6. That's false. And what that tells you is that no number will work. So there's no solution to this one. All right, you go ahead and try one. See how you do. So pause now. All right, that's it for this lesson. Go ahead and finish up your work, and we'll talk about this next time we meet in class.